I'm Jo Marini. I am the CEO and co-founder of Mothership Materials. We take agricultural waste, like the apple pomace that's left over from cider production. We use our patented technology to sort it into its molecular components, so things like sugar or lipids or proteins, and then we sell those molecules to the biomanufacturing companies making the foods, fuels, fabrics, adhesives, packaging of our future that need plant-based inputs instead of petroleum-based inputs to make it real. Our first corporate contract is with the world's largest brewery, and their plant in Syracuse, New York produces about 150,000 tons of spent grain waste every year. A truck comes up, takes it away for feed, and the brewery gets about $3 million in return. In February of 2026, we install our first microfactory on site. We take that same spent grain, we turn it into glucose for precision fermentation, protein concentrate for feed, and lipids for personal care. And that $3 million payout becomes an $8 million payout. And that same business model won us our first $30 million contract, brought in a $100 million inbound pipeline from the largest corporates across the world, and works for every farmer, grower, and food processor with almost any waste stream in the Grow New York region. Apples, spent grain and mash, dairy, hemp, grapes, we have you covered. I'm a 4-time founder with 2 exits in food and agriculture. My co-founder, Dr. Agnes Oostephen, is the author and inventor of the 9 patents that power our technology. It's called Trace, and it has 2 parts. The first part is a capture particle. Think of it like a microscopic sticky M&M. The second part is a density gradient centrifuge stack. Think of it like some big turntables stacked on top of each other with a special geometry that exists on the inside. When we put them together, we get a giant industrial molecular coin sorter. It can take in about 5,000 gallons of biomass per hour, and the molecules in that biomass interact with our capture particle. We make ones to attract lipids. We make other ones to attract sugars. We make other ones to attract proteins. And then they self-organize into their own density gradient highway while we spin that stack of turntables at a low RPM. We exit the capture particles, collect each individual molecule, and one input can make up to 5 molecular outputs. So the unit economics here are completely transformative. We can do this because unlike any other technology that is trying to do a feedstock recovery today, we use physics and not chemistry. Physics is scalable. It is low cost. It does not use heat or chemicals or enzymes, and it can be independent anywhere in the world. Those molecules that we capture, we sell to the biomanufacturing companies that are building the future of our material world. And right now, they basically get them in one of 2 places. The first place is that they do it themselves. And this is the equivalent of them mining their own crude oil. Not only are they doing their own proprietary process, but they're having to seek out that feedstock, do the extraction, and then put it into their process. This is not what they're built to do. The second way they get it is they get it from our food supply. So instead of that sugar going to a bakery to do cakes or cookies, it is going into a bioreactor. First of all, food should feed people. And second of all, the carbon economics of that food-based input into a bio-based process doesn't make sense. In both of these situations, it is too expensive to commercialize at scale. It is too expensive to compete with commodity or conventional products in market. With Mothership, we are already able to produce these at 20% below commodity pricing. We can co-locate supply and demand to keep that value in the regional economy and be immune to trade and tariffs and border shocks. And because we are using a waste biomass, we're able to give them the sustainability or the carbon impact metrics that they need to build their products on. Biomanufacturing is a $4 trillion industry that is completely bottlenecked by the lack of infrastructure to provide the inputs that it needs. There are hundreds of thousands of companies all over the world tackling our most challenging new material problems, and there are hundreds of them doing that right here in the Grow New York region. So, quick recap. We co-locate microfactories at farms and food processing sites. We use our technology to sort out the molecules that are needed up to 5 times cheaper than conventional sources, and we sell those molecules to biomanufacturing companies so that they can win on price, performance, and impact every time. We released our first product last month publicly. Within 72 hours, we had 30 companies on the waiting list, which equaled a 2x demand over our ability of our first contract to supply it. We also have our manufacturing and build partner with Rebuild Manufacturing in Rochester, New York. Our CTO, Dr. Amanda Parks, is a 3-time founder. She is an MIT and Stanford educated mechanical engineer and has experience deploying hardware in industrial settings. She is working with them on a step-repeat design that fits together like Legos, can go anywhere in the world in weeks, not months, and oftentimes with very little to no permitting. Because we are manufacturing here, we are able to protect our trade and IP secrets in the region and scale regional manufacturing and technical jobs as we grow globally. This is the Corning glass model. Let's talk about regional impact. $250K gets us 2 quality pilots here. Obviously, we're still manufacturing in Rochester, and that gives us about 13 direct jobs in the next 2 to 3 years. At $500K, we have a pilot system for material innovation trials on a small scale. We can commit 3 of our first 15 microfactories to the region and gives us about 20 jobs. $1 million builds the global biomanufacturing ecosystem from New York. It gets our entire existing R&D tech team and the new tech team hires to Ithaca this summer. It creates the first trace biomaterial development hub, which means education, collaboration, and unlocking new feedstocks in rapid time. Commits 9 of our first 15 microfactories to the region and will provide about 70 jobs over the next 2 years. All right. Our revenue model and our unit economics become exponential when there are 20 units in the world. That means that by Q2 2027, when we hit that milestone, we can hit our first 100 million year at the end of 2028 and be able to scale to 300 million revenue by 2029. To wrap it up, the Mothership Materials team is experienced and complementary. We are operators, technologists, and engineers. We have a commercialized tech that is ready for industrial deployment. We have a validated business model that our customers are so excited about. And this business is built to scale fast on purpose across suppliers, buyers, markets, and jobs, every dimension. We have a patented best-in-class technology that can do something that no other technology can do right now. And we are committed to local jobs and global deployment. The last thing that I want to say is that Mothership Materials is a New York company. And all of this success that I just outlined would have not been possible without the support of New York State. We are so proud to build and grow here, and we are so excited to keep growing together. Thank you so much.